Latitude. The equator is a circle halfway between the north and south poles that divides Earth into the northern and southern hemispheres. Imaginary lines drawn around Earth parallel to the equator are called lines of latitude, or parallels. Latitude is the distance north or south from the equator. Latitude is expressed in degrees, as shown in Figure 2. The equator represents 0 degrees latitude. The North Pole is 90 degrees north latitude, and the South Pole is 90 degrees south latitude. North latitudes are found between the equator and the North Pole. South latitudes are found between the equator and the South Pole. Longitude. Lines of longitude, or meridians, are imaginary lines that connect both poles. Longitude is the distance east and west from the prime meridian. Like latitude, longitude is expressed in degrees, as shown in Figure 3. The prime meridian is the line that represents 0 degrees longitude. Unlike lines of latitude, lines of longitude are not parallel. Lines of longitude touch at the poles and are farthest apart at the equator. Unlike the equator, the prime meridian does not completely circle the globe. The prime meridian runs from the North Pole through Greenwich, England, to the South Pole. The 180 degrees meridian lies on the opposite side of the Earth from the prime meridian. Together, the prime meridian and the 180 degrees meridian divide Earth into the eastern and western hemispheres. East lines of longitude are found east of the prime meridian, between 0 degrees and 180 degrees longitude. West lines of longitude are found west of the prime meridian, between 0 degrees and 180 degrees longitude. Using latitude and longitude. Points on Earth's surface can be located by using latitude and longitude. Lines of latitude and lines of longitude cross. They form a grid system on globes and maps. This grid system can be used to find locations north or south of the equator and east or west of the prime meridian. Figure 4 shows how latitude and longitude can be used to find the location of your state capital. First, locate the star that represents your state capital on the map. Then, use the lines of latitude and longitude closest to your state capital to estimate its approximate latitude and longitude. Information shown on maps. Maps provide information through the use of symbols. To read a map, you must understand the symbols on the map and be able to find directions and calculate distances. Regardless of the kind of map you are reading, a map typically contains the information shown in Figure 5. This information includes a title, an indicator of direction, a scale, a legend, and a date. Modern map making. Data used in many of today's maps are provided by the process of remote sensing. Remote sensing is a way to gather information about an object without directly touching or seeing the object. Today, most maps are made from photographs taken by mapping cameras that are mounted on low-flying aircraft. However, map makers are beginning to rely on more sophisticated instruments. These instruments are carried on both aircraft and Earth-orbiting satellites. Figure 6 shows an image taken by a satellite. Passive remote sensing. All objects on Earth's surface emit electromagnetic radiation, such as heat or X-rays. In a passive remote sensing system, sensors record the amount of different kinds of electromagnetic radiation that is emitted or reflected by objects. The data are gathered by a satellite-mounted sensor and are recorded as a series of numbers. These numbers are beamed to a ground station. There, a computer processes the data and converts the data into a satellite image of Earth's surface. Active remote sensing. An active remote sensing system produces its own electromagnetic radiation and measures the strength of the return signal. In an active remote sensing system, radar is used to gather data. Radar gathers data by using microwaves. An advantage to using microwaves for remote sensing is that they can penetrate clouds and water. Therefore, microwaves can be used to map areas that are difficult to study. Global Positioning System. Did you know that satellite technology can actually keep you from getting lost? The Global Positioning System, or GPS, can help you find where you are on Earth. GPS is a system of orbiting satellites that send radio signals to receivers on Earth. The receivers calculate the latitude, longitude, and elevation of a given place. Figure 7 shows how GPS works. GPS was invented in the 1970s by the U.S. Department of Defense for military use. However, during the last 30 years, GPS has made its way into people's daily lives. Map makers use GPS to check the location of boundary lines between countries and states. Airplane and boat pilots use GPS for navigation. Businesses and state agencies use GPS for mapping and environmental planning. Many new cars have GPS units that show information on a screen on the dashboard. Some GPS units are small enough to wear on your wrist, as shown in Figure 8, so you can know your location anywhere you go. Geographic Information Systems. Geographic Information Systems, or GISs, are computerized systems that visually present information about an area. A GIS organizes information in overlapping layers. Scientists can compare the layers to answer questions. Figure 9 shows how GISs helped scientists plan conservation areas for Florida black bears near Ocala National Forest, located northwest of Orlando. Well, we've reached the end of this section. Review the main points of the section by reading the summary. Then take some time to demonstrate what you've learned by answering the review questions.